everyone, myself Sravanthi, working as Assistant Professor in the Department of Data Science and Cybersecurity in MLR Institute of Technology. Today our topic is classification of bottom-up parsing. So here we are going to discuss what is bottom-up parsing, what is the definition, and what are the steps that we are going to find, and how we are going to classify what are the different types of bottom-up parsing. So first, initially, what is bottom-up parsing? So bottom-up parsing is nothing but it is basically a syntax analyzer or syntax analysis we can call, where the parser starts from the input symbol and attempts to reduce them to the start symbol of the grammar, usually denoted as S. So here the name itself tells us that it is a bottom-up parsing. Here we are going to call this bottom-up parsing as a syntax analyzer. We are going to call it as a syntax analyzer. Syntax analyzer is nothing but it is a parser. It is a parser. Here we are going to take the input string and we are going to reduce these input string to the start symbol. The start symbol is nothing but it is denoted by S. It is denoted by S. So that is nothing but bottom-up parsing. For example, I have some string or some input string is there. Some A, B, B, C is some input string is there. Now I am going to derive these input string until I get a start symbol. So this start symbol is nothing but we are going to have it in the grammar. So we are going to derive these input string. Nothing but from the leaf node to the root node. That's why we are going to call it as a bottom-up parsing. The process involves applying production rules in reverse, starting from the leaves of the parse tree and working upwards towards the root node. So nothing but we are going to take the input string and we are going to derive these input string until I get a start symbol. Nothing but I am starting from the leaf node and I am going to generate a root node. So nothing but it is in the reverse order. Actually, in the top-down parsing, what it happens is we are going to start from the root node. Nothing but from S we are going to start and we are going to derive this root node till I get a leaf node. Leaf node is nothing but till I get a input string. So that is nothing but we are going to call it as a top-down parsing. But coming to here in bottom-up parsing, we are going to take the input string, nothing but the leaf node, and we are going to generate the start node, nothing but the start symbol. So that is nothing but in reverse order. How we are going to generate? By applying the production rules. Where I am having these production rules? In the grammar. From these grammar, we are going to apply the production rules. Nothing but if I find any substring in the grammar, we are going to replace that. Nothing but we are going to handle the substring by replacing it with the left side non-terminal. Then we are going to get the start node. So this is nothing but bottom-up parsing. So it is nothing but reverse order. We are going to generate the root node by taking the leaf nodes. Starting from the leaves of the parse tree, I am working upward towards the root. So we are going to take the leaves as the input string and we are going to generate the root node. So this is bottom-up parsing. It is also called a syntax analyzer. It is nothing but a parser. Examples. We'll see the example. So this is my grammar. A grammar consists of productions. Okay, this is nothing but LHS. It is having a non-terminal. And coming to the RHS, I am having a terminals and non-terminals. It's a combination of terminals and non-terminals. So let us take this is my input string ID into ID is the input string. Now I am going to apply the bottom-up parsing for this input string. So what is bottom-up parsing? Or bottom-up parsing is nothing but we are going to read the input string and we are going to generate the root node. Taking the leaf nodes and we are going to generate the root node in the bottom-up parsing. So that is nothing but we are going to call it as a bottom-up parsing. So let me take the first step is ID into ID. That is my input string. So what I am going to do, we are going to apply the leftmost derivation. So first ID. Let me check if any handles are there for this substring. Handle is nothing but here if I find the substring in the given production, then replace that handle with the left side non-terminal. So that is nothing but we are going to call it as a handle. Here see, ID is there. So let me check in the production, in the grammar where I can handle this ID. See here, I find this ID here. So ID is handled by T. Nothing but the right side non-terminal, right side terminal or the substring is replaced with the left side non-terminal. See, ID is replaced with F. So first initially we are not going to replace. See here, F. ID is replaced with F. Here I have in the two places, I can replace it with T or I can replace it with F. I initially replaced with F. Doesn't matter F or T. You can do anything. But if I do with, yes, we can do with anything. ID tends to F. So F into ID. Still I can reduce this F. Still I can handle this F. Yes, I can handle this F. So how I am going to handle? F is handled by is nothing but T is handled. So F can be handled with T. So T into ID. So again, can I handle T star? Is there any production? There is no production with T star. Now replace the next ID. ID is replaced with F. ID is replaced with F. So what it happens? ID is replaced with F. So F. T star F. Check it. T star F. Any production is available T star F in the right side non-terminal? Yes, I find the T star F. I can handle this T star F by left side non-terminal T. T star F is handled by non-terminal T. So as it is a start symbol, no, it is not the start symbol. The first substring is nothing but the first production is the start symbol. Now T can be replaced with E. Nothing but I can handle T with the E. So T is handled with E. I have started from the leaf node and I have reduced it to the start symbol. So nothing but this is nothing but we are going to call it as a bottom up parser. Bottom up parsing. Started from the leaf node and I am going to slightly reduce it until I get the start symbol. So this is bottom up parsing. So when I am going to reduce this one, let me check any productions are available. If I find that one, we are going to replace nothing but we are going to handle this substring with the production. So let me take one more example. So this is my grammar. S tends to A, A tends to A, B, C, B tends to D. So the input string is A, B, C, D, E is the input string. So let me check A, B, C, D, E. So what is the first string what I am having? Here A, B, C, D, E. So let me check. First string I have, let me check A, B, C, D, E. So let me check A. The first, we are going to start it from the leftmost derivation. A. Anything is there? And I can handle A from the given grammar? No, no productions are available with A. So I'm moving to the second string. So B. Let me handle this B from the given production. Yes, I can handle B with the help of A. So now replacing these with how I am going to replace A, B, C, D, E. A, B, C, D, E. So now it is handled. Can I replace now this one? A, B, C. A, B, C. The substring I can handle. Yes, I can handle A, B, C with the help of A. So now we are going to replace or handle A, D, E. A, D, E. Is there any substring with this name A, D, E in the production? A, D, E. There is no production. Can I handle D? Yes, I can handle D with the B. So A, B, E. A, B, E. This D is handled with or replaced with the B non-terminal. Now A, B, E. Anything is there? Yes, I can find. So nothing but it is the start symbol. I have taken input string and I have generated the start symbol. I have taken input string and I have generated the start symbol. So nothing but we are going to call it as a bottom up parsing. Coming to top down, what we are going to take? We are going to take these S as the start symbol, nothing but the input string. Root node is my input string and we are going to generate, see here, A, B, E. Now what is the next one I am going to replace? B, E. Next string is D, A. So these two are done. D, E. A can be replaced with A, B, C, A. Now again A can be replaced with A, B, C, D, E. So from this root node, we are going to generate the leaf node or the input string. This is called as top down. This is called as bottom up parsing. This is called as bottom up parsing. So this is the difference for top down and bottom up parsing. See, I have started here. I have replaced this one with the A. Then again, I am replacing this whole with the A. Next, I am replacing this D with the B. Next, I am replacing the total with the S. So this is nothing but bottom up parsing. Classification of bottom up parser. So the bottom up parsing is classified into shift reduce parsing. Again, this shift reduce parsing is divided into two types: operator precedence parsing, LR parser. These LR parser is again divided into LR of 0 parser, SLR of 1, LALR of 1, CLR of 1. Okay, so bottom up parsing is nothing but which we have seen just now. And coming to the shift reduce parsing is nothing but these are nothing but the different types of parsing techniques. Here to do this parsing, we are going to apply shift and reduce actions. There are two types of actions we are going to follow in shift reduce. Shift and reduce. Shift is nothing but I want to push or I want to shift the input string to the stack. Reduce is nothing but we are going to reduce the substring from the substring with the help of the terminal, with the help of the grammar. That is nothing but shift reduce. We are going to follow two actions here. So that's why we are going to call it as shift reduce parsing. Coming to the operator precedence parsing. Here operator precedence parsing is nothing but we are going to generate or we are going to have operator grammar. Operator grammar is nothing but what we are going to have is here the terminals, the two contiguous non-terminals should not be exist. Here operator grammar is nothing but it can have between the two non-terminals, they should have a presence of terminals. Then we are going to call it as a operator grammar. Coming to LR parser. So these LR parser is applied on unambiguous grammars. This LR parser is applied on unambiguous grammar. So L is nothing but we are going to scan from left to right. R is nothing but we are going to apply rightmost derivation. We are going to apply rightmost derivation. So here there are four types of parsers are available. LR of 0 parser, SLR of 1 parser, LALR of 1 parser, CLR of 1 parser. So nothing but these are the different types of parsing algorithms we are going to apply here by using these actions, different types of actions. So this is nothing but the classification of bottom-up parsers. So what is shift reduce parsing? The shift reduce parsing is a process to reduce a string to its grammar, nothing but the start symbol. It uses a stack to hold the grammar and an input to hold the string. Shift reduce parsing performs two actions, shift and reduce. So that is why we are going to call it as shift reduce parsing. So nothing but what we are going to do, we are going to reduce the string. For example, I am having some input string A, B, B, C is my input string. Now I am going to reduce this string. How we are going to reduce this string? If I find the substring in my grammar or in my production, then I am going to apply reduce. Then I am going to apply the action or operation reduce. Next, shift is nothing but the start symbol or the string, input string. We are going to shift each substring or each character to the stack, each character to the top of the stack. So nothing but we are going to apply shift. We are going to shift the input string one character to the top of the stack. So that is nothing but shift action is performed. The next is reduce. Reduce is nothing but we are going to handle or we are going to replace the input string with some production. So that is why we are going to perform two actions, shift and reduce. So that's why we are going to call it as shift reduce action parsing. Next, LR parsing. LR parsing is nothing but it is a bottom-up parser for context-free grammar. LR parser reads the input from left to right. LR is nothing but it reads the input from left to right, and R is nothing but rightmost derivation. L is nothing but we are going to scan from left to right. For example, I am having some example. We are going to scan from left to right and we are going to apply the rightmost derivation on the given grammar, on the given input string. It is called a bottom-up parser. Why? Because we are going to reduce the top level. Nothing but we are going to take the input string and we are going to generate the start symbol or root symbol. So that's why we are going to call it as bottom-up parser. LR parser is divided into four categories. LR of 0 parser, left to right scanning, left to right scan, rightmost derivation. 0 is nothing but there are look ahead symbols as 0. So we are having LR of K. K is nothing but we can have K number of look ahead symbols. Here if I have 0 is nothing but 0 look ahead symbols. SLR of parser, nothing but simple LR parser. CLR is nothing but canonical LR parser. LALR parser. So these are the different types of parser techniques we are going to have. So we are going to check what is the basic structure of the LR parser. To apply those four parsing algorithms, we need to have some structure. So here we are going to have the input buffer or input string, and I'm going to have a stack, and I'm going to have the parsing algorithm, and we are going to have the in the parsing table action go to. Here for coming to the all the four parsers, LR of 0 or LALR or SLR, CLR of 1. So all these parser techniques, all these parsing techniques follow the same structure. will have the same stack, same input string, and output we are going to apply the parsing algorithm. Nothing but if I apply LR of 0 algorithm, if I apply LALR of 1 algorithm, SALR of 1 algorithm, or CLR of 1 algorithm, nothing but here based on these algorithm, the parsing table is going to be changed. Remaining all the things are same in the structure of LR parser. Only based on the parsing algorithm. Based on the parsing algorithm is nothing but based on these LR of 0 algorithm, or LALR of 1 algorithm, or SLR of 1 algorithm, or CLR of 1 algorithm. So based on that, my parsing table is going to be changed. Stack is remaining same. Input buffer, nothing but input string is same, and the output is based on the algorithm, it is going to generate the output. But only the parsing table only differ when coming to the remaining all things. Stack is nothing but it holds the bottom of the string. Stack is dollar. Okay, it indicates that this is my start of the stack. Input string, input buffer or input string ends with dollar. It indicates that this is my end of the string. I can apply actions and I can apply go to string and action. Action is nothing but there are 4 types of actions are there: shift, reduce, error, accept. These are the 4 types of actions are going to available. So this parsing table is going to be changed based on the algorithm. Remaining all the things are same. So what we have discussed here is overview of this is what is a bottom-up parsing, how to define the bottom-up parsing. We are going to start from the leaf node and we are going to generate the root node. Nothing but we are going to apply the bottom-up parser. Reverse direction we are going to follow. And we have seen the classifications of bottom-up parsing. It is classified into 2 types. First, the bottom-up parser is nothing but the shift-reduce parser. Again, the shift-reduce parser is divided into operator, precedence grammar, and LR parser. LR parser follows unambiguous grammar. It uses only unambiguous grammars for all the different types of parsing algorithms. Coming to the operator precedence grammar, it uses same like context-free grammar. We follow or we use context-free grammar. In the same way, operator precedence grammar uses the operator grammar. Okay, so that is the classification, and we have seen the structure of the LR parser. How the structure will be? We are going to have the input string that is given to the parsing algorithm. The stack generates. We are going to shift the elements or shift the input string to the stack based on the parsing table. All these things are done. This is the basic structure of LR parser. Thank you.